map this one. So like this is the monitor. Monitor is the address 0000. Okay. Then the hard disk drive 0 is a 0F. At the A. And this one is the next address. So instead of defining all the device and the data, the instruction just call address. And each address is dedicated to the specific hard I/O devices. So this is called the memory map I/O. Okay. So from the CPU point of view, which means programming and the assembly part, it's very simple. You don't have to worry about after you define this one memory, then we don't have to worry about. So who defined this? Operating system actually provide this one. If this address is called, then something the handler will be used to read the data. This is called the memory map I/O. Another thing is each port, as we have seen before, the I/O, the hardware has a port and the bus and so on. So port, it has the specific instruction. It's a direct I/O instruction. Each port has a specific. So if you have the many, so you need to define all each and every instruction. Okay. So nowadays, which one will be popular? Obviously, memory map I/O is popular. However, so let me show you the one example in our PC. What is this? This is if you type for example, resource manager. Yeah, this one. This is a command utility in your operating system that if you see the resource manager, you can check the CPU, memory, this. What about your Linux or Unix? You can use several this monitoring specific command, like the top command or VM state or the MP state or the IO state. You can check it. This is the integrated monitoring tool provided by the Windows. So this is the in-use memory, okay? And this is a standby and the free. I have enough the memory in my system. It's 8 gig. What about this one, beginning? It's a hardware reserved memory. Memory is reserved by the hardware. This is used for memory mapped I/O. So when CPU read the data, actually call the address of the memory that is associated with the specific I/O device. Then who defines such the connection dedicated part? Operating system use program this one, so you don't have to worry about how to detect read the data. So this part is actually used for such a memory map I/O. Problem? It's limited by what? Memory address format. Okay, that is a limitation. So there are advanced or something generate the data structure to make the generate the address format. But basically use the same idea. Nowadays, even Windows system try to catch up the functionality that are used a lot in the Linux system. Actually, we didn't have such a resource monitoring tool in Windows. Microsoft make the very similar as with the Linux system or the graphical user interface. Okay. Where's the slide? So that is the memory mapped I/O, and now you can understand the memory mapped I/O or direct I/O instruction. Okay. And these are the details of the address. The DMA controller is here, and the intro controller is here, and timer. What is a timer? I think we talk about the slightly timer. how does the computer understand time? Time. CPU cycle. It's electronically, it's a CPU cycle. But what is this? By the way, time is a conceptual level. It's not real thing. Okay? Physically, is there the real time? It's a human being defined. This is the time. Scientifically, we try to present the time. Like the 1 year is the cycle of the rotation. Okay? The 1 day is a rotation of the Earth, but the scientifically we represent. But concept of time itself is nothing. Same thing. Then when we define the time in the computer, because there is no existing, so it's not realistic. So from the hardware point of view, the computer engineer, define the time as the something clock, the period. Okay, it can be tic-tac-toe or the CPU cycle or whatever. Actually, not CPU cycle. Even you turn off the CPU, it's still running using the battery. It's something the periodic signal keep doing. From when? 1970, January 1st, 0000. Because of that, if you removed your battery, all the power, even though you turn off, you are out of battery, still your time is not changed, right? Why? Because there is a system battery, so that keep alive such a periodic signal. Then this signal is called a timer. That timer is the system timer. Okay, it's not our time. It's just something periodic signal. Okay, then count. For example, for 1 second, how many? And then, if we define using such a periodic signal for 1 second, then minute, hour, year is not a problem. Okay, that is the real time. Okay, our time, the human being time. So there's another time that you are using, that is like the 2017, so right now November 20. November 20 is? November 20 is? I should remember. Thanksgiving? No, it's more important. Today. It's my wedding anniversary. So, yeah, it's especially this year is the 20th. Is there any special thing? It's both, right? It's not one side. Why? You need to care, right? It doesn't make sense. Are you married? So anyway, so that is the time. So you can then reversely you can count the 19, for example 45. But from the system line is starting from the January 1st, 1970, and such a thing. Okay, so this is timer and so on. So this address is used for the I/O. This is memory map I/O. Okay, then another approach to read the data, to communicate the data is the polling. So we have seen so far the interface. The interface is you can stop all the system, then communicate. Another approach is the polling approach, which means I try to read the data for the hard disk drive, then keep checking whether this hardware is available or not. You cannot read the data at the same time, exactly same time. Okay? Because of that, each device manages the ready queue. Okay, which one is ready? Which one is the request queue? So, but you need to keep checking this one. So then if available, each the controller device means the controller. Controller has mostly what is a controller? Controller is a hardware. It's kind of embedded system, which means it has the instruction. there are 4 popular instructions used in the controller. I think somewhere here, I'm not sure. I think there is not here. So one is the read, IO, and another one at the send, receive, the receive, send, and control, and the status. Name can be various. Name can be various depending on the hardware, the I/O devices, but mostly receive, send, receive and send, and status and the control. Control means like if you are using the modem. Is there anyone who are using the modem for communication? Probably not. The PC modem, the modulator, demodulator, and then there are 2 types of the communication: half duplex or full duplex, something like that. So the control will be set by the control, the register, control the instruction, and another one is the receive and the send the data. But this one is the status is whether it's mostly being used, in use or not. So if this status is off 0, then we are able to read. Keep checking. That means it's a busy waiting. The other was straightforward, how to read the data. So this is the polling approach. The biggest problem is the busy wait. Okay. So interrupt-based address such a problem by using such a thing. So let me quick summarize. The interrupt-based is in case you have the input and output, I/O the event, you can just start your operating system using the interrupt. And each one has the specific IIQ number. Then if that one is the code, then the interrupt handler. Interrupt handler is think about the error handling in the program. Try, catch, and do the action. So such an action is the part of programming is the interrupt handling. Okay, then they can be defined by the interrupt vector. So each operating system has such an interrupt vector. Okay, so this is the schematic diagram how the interrupt-driven I/O is happening. This is the what I explained so far. So these are the event handler, the vector table. So you can see the 0 is divided by 0, and this the case are defined. Okay. Then we can call the interrupt handler, call operating system, call the specific action. Okay. In case of divide by 0, it's a start. Okay. And the debug and so on. Then however, most of the frequently happen, the I/O in the computer system is read the data from the secondary storage to the computer, your operating system. So think about what happened when you read the data. So from the CPU, if a CPU encounter like the move or the in or out such a I/O instruction, then what happened? Interrupt and send the request to the controller. Okay, controller, hardware, hard disk drive controller receive that. Then inside the hardware controller, hard disk drive controller, if there are a lot of the requests, we have seen how to read the data, schedule, how to schedule the I/O the last time. So then read. Then meanwhile, CPU cannot do anything, just wait. So we can run the CPU scheduler. So CPU scheduler will select another process to use the CPU resource. Meanwhile, hard disk drive to read the data and send it back to the operating system. Not yet, just wait, and then using the instruction and interrupt start. Then send the data to where? Memory. Then that is one cycle of the I/O. So whenever you read the data, you need to do this one, which means there are a lot of context switch. There are a lot of interrupt, and there is a delay of its performance will be degraded. So to address that problem, once think about the I/O. When you read for example, the images, at least you need to read the 4 megabyte size data sequentially, all of them. If you run this cycle per byte, it will be huge overhead. Okay, you need to stop and the context switch and the interrupt and read the data, interrupt again, and then the copy. Then it will take a longer time. So to address that one, in case when we read the data, some of the sequential data, we bypass all the additional things, like for example, context switch and the interrupt. And the interrupt again when you are done. Instead of using such a thing, just directly move the data to the memory. This is called the direct memory access. So direct memory access to avoid such an overhead of the I/O cycle. Okay? At that time, it needs a specific hardware. Hardware means also controller, because all the I/O devices are connected to the bus using controller. So it uses a specific DMA. So it's called the direct memory access, the controller. Okay? Then this is the diagram for the DMA. So from the CPU, so we can use the specific hardware, the DMA, but a DMA controller. Then using the controller, we can directly move the data without such a CPU related to the instruction, just to copy all the data to the memory. Okay. So that is nowadays most of the operating system most of the computer use the DMA. However, DMA is not just the programming level. You need the hardware specific. The hardware is support the DMA. I'm going to quickly go over the application I/O interface because we have talked a lot before. Okay. So in the Unix system, the system library that supports the I/O is the I/O related one is IOCTL, the system library. So in case you are doing the system level programming, you can mostly use the IOCTL system library for the implementation of the I/O related programming. You can do the IOCTL. Keep in mind that IOCTL. Then there are the libraries supported, like the get and the put of the command. I'm going to skip the network devices and the clock and timer. So I already mentioned the clock and timer. So it's interval timers. There are two types of the timer. One is a system timer. Another one is the real timer. System timer is just the periodic signal, and on the other hand, the real timer is a human, like the time, like the January 1st and so on. There are different types of I/O. We already discussed before, synchronous or non-synchronous blocking and non-blocking, so which are supported in the I/O. So basically the synchronous is when you send the data, then confirm, then next the data block will be sent. On the other hand, the asynchronous is you just keep sending, you don't care whether that data is received or not. Okay? The asynchronous will be the faster, definitely, but you need to check from time to time whether you received the correct data. Most popularly used checking the status of the data status you receive is the parity check. You can use the parity check whether the data are corrected or not. When you see the instruction, so when you are doing the the project 1 and project 2, you probably see sometimes some of the instruction has the, and some of the system library has the, like the VE. The VE usually means it's a vector. So vector, what is a vector? What is the opposite of vector in mathematics? Scalar. What is the difference between the scalar and the vector?
Unidirectional parameter.
So vector, there is no actually the physical location, place of the data, unlike the scalar. But it has only direction, okay, and the how much the big, okay, how much big that the vector is. So it consists of what? Number of scalar value. Because of that, when we process a lot of the same operation, we can combine together and process all together. So because of that, we can use sometimes I/O is not just a read byte by byte by byte. It will happen together. So we can do the vector I/O, that is the kind of grouping of the data input and output. So whenever you see the VE or V, that is the kind of grouping together such an operation. Then the operating system supports some of the system to support the better performance of the I/O. We already seen the the buffering. Okay, what is the difference between the buffer and cache? Cache, usually you can reuse the data for the faster device, okay, like the memory instead of the secondary storage. Buffer can be used, it's the in between. It's the same as the cache in terms of the location of that. It's the in between. For what? Faster and slow device. So when you read the data from the faster to read the slow device, you cannot get the full benefit of the speed. So you can keep the certain amount of the data in buffer, then read later, deferred reading. Then you may not realize such a gap between the gap of the speed or bandwidth. It's used a lot in networking. So network, so higher bandwidth, lower bandwidth, you can put the buffer in between. It's the same idea when you read the data, you can use such a buffer area so to reduce the gap. Caching is, I already. What about the spooling? Have you ever used a spool? It's a printer uses spool, which means the cache or the buffer, you can, when you read the several different jobs, you can stop and you can do the scheduling. You can stop and it's a preemptive. However, sometimes you can keep all the job requests. In other words, I/O. Then you can select one of them. Once you select them, so it's you need to wait until it is done. So it's more like the long-term scheduling. It's for the long-term scheduling. Yes. This one? Yes.
Just wanted to know the last one.
Oh, okay. Okay, so I think that the others are pretty much example of the, I'm not sure whether Y is a power management here. This is an example of the I/O, the subsystem. You don't have to worry about. Okay, so I think that's pretty much enough for the I/O management, because we already talked a lot, most of the contents in the I/O management. So let's have the with